Don't worry, everyone, I'm here.
All right, so quiz grades are in. Hopefully you had a chance to see them. Very, very nice. You will get them back whenever the next class can finish theirs. They're taking theirs today. Okay, so as long as everyone takes it today in that class, you'll get them back tomorrow. All right? In the meantime, we're going to move on to the next section. Really short section. We're probably hopefully just going to cover it today. But we're going to be on page 39. We're going to take a look at limits specifically dealing with exponential functions. Okay, that exponential growth or decay that we've kind of seen a little bit this year, at least at the beginning of the year when we were looking at all those different types of graphs. Before we get started today, though, I just want to bring this up. Tomorrow, we're going to have our first homework quiz, okay? Refresh your memory on the syllabus. I'll remind you today, but you got the syllabus last year when you had your summer assignment, so it may not be fresh in your mind. But I don't collect the homework in here until the end of the unit, whenever we have our unit test, okay? But in the meantime, I want to check to make sure you're keeping up with it, and I do that by giving you a homework quiz. So we're going to have our first one tomorrow. This is the only one I'm going to announce. Okay, all the other ones the rest of the year, you're just going to come in and we might have one that day, we might not. Okay, so you got to make sure you're keeping up with the homework.
What do they consist of?
Okay, so the homework quiz, you're going to have 5 questions. And up to this point, we've only covered 2 sections. Okay, notice how we're on day 10 today. So if you look at your table for the unit, you got to make sure that you have all the homework problems done up to this point. Okay, that covers the last 2, basically the homework sections from the quiz we took on Friday. Okay, those 2 sections. So 5 questions, it's basically going to look like on page 5, what was your answer to number 2? On page 7, what was your answer to number 10? Something like that. Okay, you're going to just write down the work you have for that problem and your answer, and you're done. Okay, so just 5 questions like that. The homework quiz I grade for accuracy, so you got to make sure that your homework is correct. When I collect it at the end of the unit, I grade that for completion. Okay, whether you put, bless you, whether you put forth a solid effort on every question. Okay, so there's a difference between how the 2 are graded. Yes?
For this, I see that for page 10, it says that there is a homework for 41 and 42. Will that be common?
No. So for what we do today, none of the homework from today's section will be on that homework quiz. Okay, just up to this point. All right? Okay. So let's go ahead and take a look at 39. We have these 4 different exponential functions. We're going to take a look at the limits. Notice how in some cases we're going to approach all the way to the left and all the way to the right. But before we take a look at these, I just want to make sure that we're all on the same page with exponential functions. So this is what the little piece of paper is that I handed out to you that's hole punched. You can just slide it into your binder if you want to. Go ahead and on the left-hand side, I want you to label in that column. I forgot to do that when I was making copies. We're just going to make a nice go-to table for exponential functions. What we're going to basically talk about is, based on the way the equation looks for an exponential function, we should be able to determine what the graph would look like. And based off of that graph, we should be able to determine what certain limits are if we go all the way to the left and all the way to the right. So we're just going to review exponential graphs, at least for right now. Yeah. Yeah. Okay. So for this first column that we're going to fill in, we're going to assume the base value of the exponential function is bigger than 1. Like we have 2 to the x, 2.5 to the x, 5 to the x, okay, some base value bigger than 1. And then in the second column, we're going to say the base value is something between 0 and 1. Your base value will never be negative, Okay, but we are going to discuss if we do have a negative in a particular spot, how does that affect the graph? And maybe you remember some of that from last year from pre-calc and all your transformations. Okay, so let's just say, for example, that we had an exponential function 2 to the x. Based off of that exponential function, can we describe or determine the way the graph might look? In other words, exponential decay, exponential growth. What do you think, Braden?
Exponential growth.
Growth. Okay, so just as a rough sketch, okay, you have the asymptote towards the bottom and the exponential function grows upward. We discussed how if the exponential function goes away from an asymptote, it's growth. If it goes towards an asymptote, it's decay. Okay, so this is an exponential growth because that base value is bigger than 1. Okay, it makes sense that if you raise a number bigger than 1 to a power, your numbers are going to get larger, aka you're growing. Okay, but sometimes we might have negatives in our equation. For instance, what if we have a negative on the outside? Our equation might look like negative 2 to the x. If you think about your transformations, a negative on the outside flips your graph, specifically over the x-axis, okay, that horizontal axis. So instead of having this original graph, if we were to flip it upside down, it would look something like that. Does that make sense? Negative on the outside, flip it upside down. Is this new graph growth or decay? It's still growth. Okay? As you travel from left to right, it's still going away from the asymptote. Sometimes we might have a negative on the inside. Okay, what that means is the negative is with that exponent of x. And based off that location of the negative, we need to flip or reflect our graph across the y-axis. So we're going to take this original graph and fold it left or right. So instead of going low to high, it's now going to go high to low. Growth or decay? Decay. As we go from left to right, notice how we're getting closer to that asymptote. All right, and last but not least, sometimes we can have both reflections. We can have a negative on the outside as well as the inside in that exponent spot. Bless you. So we have to do both flips. Bless you. So graphically, if you can think about the only other way this graph might look, okay, we have this shape, this one. It looks like the only other option we haven't really talked about or drawn is that one. Okay, you have 4 possibilities. So if you were to take this original graph and flip it over the x, it would look like this. And then if you were to take this graph and flip it across the y, it would now look like that one. You have to do both flips. Growth or decay?
Decay.
Decay. As you go from left to right, it's going towards the asymptote. Okay? All right, let's check out what if our base value is between 0 and 1. Maybe we'll say a half. If you're raising a fraction to a power, let's think. A half squared would be a fourth. A half to the third would be an eighth. A half to the fourth would be a 16th. Notice how your numbers are getting smaller, right? So we would have that type of graph. This would be exponential decay. Again, let's check it out. If we have a negative on the outside, that flips our original graph across the x-axis. So we have to flip it upside down. That's still decay. If we have a negative on the inside with that x value, we need to flip the original graph either left or right. So now it looks like we have a growth graph. And let's say we have both reflections. The only other possibility for a graph that we haven't really seen yet is that one. And as you go from left to right, it goes away from the asymptote, so we have another growth. They coming back to us a little bit? Okay, so you can keep this handy as we go through some of the graphs today. You can just keep it off to the side, but eventually I hole punched it so you can put it in your binder. Okay, so we have these 4 different possibilities depending if the base value is bigger than 1 or if the base value is between 0 and 1. Okay, so take a look at some of these graphs. I'm not too worried about the equation just yet. Okay, we'll talk about a specific number that's kind of important, but I want to focus on the limits. Based off of this graph, as we go forever to the left, what does the function do? Can you describe the height? If you were to trace the graph to the left, what do you think, Dan?
It would go up to positive infinity.
We'd go up towards positive infinity. Good, okay. Let's say if we go forever to the right, what's the height of the graph? What are we approaching? Good, Dan?
-2.
-2. All right, exponential growth or decay? Go, Stevie?
Decay.
Decay, good, okay. And can we perhaps think about why the asymptote towards the right is -2? Notice how we kind of level off. Why do you think? Go ahead, Dan.
Because the c variable in the function is -2.
Okay, so whatever is being added or subtracted on the end, that's the location of your horizontal asymptote. Maybe you'll start to see that connection as we go through some of the other graphs. Okay, let's try the next one. For if we trace the graph towards the left, notice how we'll level off at -2. That happens to be what's being added or subtracted on the end. And if we go forever to the right, we're traveling upward. Growth or decay? Go, Joseph. Growth. Okay. Take a look at the bottom one. Forever to the left. Looks like we go down. Forever to the right. We're going to level off at -1. That horizontal asymptote. Growth or decay? Yeah. Decay. All right, and our last one, forever to the left, we're going to level off at 2. And forever to the right, we have -infinity. Growth or decay? Can we tell based off the graph? Go, Joseph. Growth. Okay. So with these 4 possibilities, I want to know if you're only going to check the left side or the right side of an exponential graph, what are your 3 possible outcomes? Can you tell based off of the limit results that we identified in those 4 graphs? Your answer is going to be one of 3 things. What do you think?
Would you like all 3 of them? Or
Sure, go ahead.
a real number,
Okay.
an integer, or something.
Okay, and that integer represents what? What was this negative?
Horizontal asymptote.
Okay, so notice how the -2, +2, and -1, that real number, integer, it might not always be an integer, it could be a decimal, but that number is representing your horizontal asymptote.
and then you have infinity, or
Yeah.
positive infinity, and then negative infinity.
Or negative infinity. Okay, so whenever you're checking the left or the right of an exponential function, not necessarily coming in from both sides of a number, okay, just left or right, you have these three possibilities. Okay, horizontal asymptote, either positive infinity or negative infinity. Let's go ahead a little bit further and think about, well, can we determine based off the limits? Maybe we didn't have a graph. Okay, let's just say we had the limits. Could we determine based off the limits, is it growth or decay? So maybe we'll check the limit as we go towards positive infinity and the limit as we go towards negative infinity. We'll check the same thing for a decay. All right, so if we think about in our heads, exponential growth, as you trace your graph from left to right, it goes away from the asymptote. Okay, so picture that in your head. Maybe you can look up the four we did at the top as for some examples. As you trace your graph from left to right, you go away from the asymptote. So, in terms of moving towards the right, towards positive infinity, of these three outcomes, which one or ones could possibly be your result for the limit? As you travel to the right, yeah. It's either going to be the positive or negative infinity. If you're going away from an asymptote, you are either going up or down forever. So that means as we travel to the left of a growth exponential, that should be the value of the asymptote. And does that make sense if we check the graphs above? Notice how as we went towards the right, it was either positive or negative infinity, and as we went towards the left, that was your horizontal asymptote value. Okay, let's check out decay. This time, as we trace the graph from left to right, we get closer to an asymptote. So, the further we go to the right, we should be approaching that asymptote, getting closer to it, which means towards the left, we're either going up or down. Notice how they kind of switch. And you can see that based off the four at the top. Notice how towards the right we approached the asymptote, and then to the left we either went up or down. Okay? All right. So let's go ahead and think about, well, maybe we don't have a graph, because sometimes that's not the case. How can we tell if it's exponential growth or decay based off of the function, based off the way the equation looks? So this is where I want you to use your little table that we did to kind of help you out. Okay, let's say that we're dealing with a growth graph. Okay, and specifically our base value is bigger than 1. Okay, so if you take a look at your table we did, okay, we're in the first column and we're trying to identify just the growth graphs. So that would be our first two. Okay, so if our base value is bigger than 1 and we have a growth graph, notice how we either have no reflections, right? That's just our beginning graph, or we have an x-axis reflection. So we have a negative on the outside. Okay, so in this case, we either have no reflections or an x-axis reflection, meaning the negatives on the outside. Let's go ahead and do the same thing, but this time our b value is between 0 and 1. So go ahead and take a look at your table on the right-hand column, looking for those growth graphs. How can we determine based off the equation if we're growing if our base is between 0 and 1? where are the reflections located? Or what type of reflections do we have? What do you think, Joseph?
Y-axis or the...
There we go. Okay, so base between 0 and 1, we either have a y-axis reflection or we happen to have both reflections. So we'll say y-axis or both. All right, let's check out decay. If our base value was bigger than 1 and we have a decay graph, what type of reflections might we have? It's all about those negatives. Yeah.
Y-axis or both?
Okay, and if we have a base between 0 and 1, maybe you can see a pattern with what we've done so far. Notice how if we had a growth between 0 and 1, it was y-axis or both. If we had a decay bigger than 1, it was also y-axis or both. So then decay for between 0 and 1 should be the same as the growth with a base value bigger than 1. So we either have no reflections, no negatives, or an x-axis reflection. And maybe we'll take a look at that. Okay, if our base is between 0 and 1, notice how we either had no reflections, no negatives, or x-axis. Okay, so no more graphs. We're going to go ahead and take a look at where the negatives or reflections are located in an equation to help us determine what the actual limits might be. Okay, notice how we don't have any graphs here. So take a look at number 1. Can we identify some type of reflection based off that equation? We're just looking for negatives and where they're located. Can we find it? Yeah.
Over the y-axis.
How'd you know?
There's a negative in the x.
There's a negative in the x. Okay, so we have a y-axis reflection. All right. What's our base value? Is it bigger than 1 or is it between 0 and 1? 2/3? Between 0 and 1. Okay, so can we determine if it's exponential growth or exponential decay? Can you tell based off the top? Yeah? Okay, notice how we have y-axis with a base between 0 and 1, so it is exponential growth. Now the question is, okay, is it exponential growth going up or is it exponential growth going down? What do you think? Can we reason through it? Let's see. If we originally had a base between 0 and 1, the exponential function looks like that, right? Okay? And if the only reflection we had was y-axis, that means this graph is now folded left or right. So it looks something like that. Do you see how it never flipped upside down? So if these are our only two options, then this is the one that makes sense, because we only had the y-axis reflection. Okay, so this is what a decay base value between 0 and 1 originally looks like, and if we do a y-axis, we're flipping it left and right. So now the flat part's on the left and the tall part's on the right. Does that make sense? Okay, So let's go ahead and figure out the limit. This specific limit is asking us, the further we go to the right, what does the graph do? So we already determined its exponential growth, partly because we were using this number 2 from above to help us. Maybe you could figure out what the graph looks like to help you with that. But if it's exponential growth, we know we're either going up forever or down forever, specifically to the right. So the way this graph looks, it looks like our limit value would be infinity. What's the value of that horizontal asymptote? Not that it's necessary for this question, but what's the -2, right? Okay, we have that being added or subtracted on the end. No, you're not. Okay, let's try the next one. Where's the negative? What type of reflection do we have? Can we identify if the base is bigger than 1 or in between 0 and 1? And from there, we can either use our little shortcuts up here or try to think about what the graph might look like. Any thoughts? Let's start with the reflections first. Where's our negative located? Good, Braden?
Outside.
Outside. All right, so we have an x-axis reflection. Notice how our base 0.4 is between 0 and 1. So go ahead and use your little shortcuts up above, 1 through 4. If your base is between 0 and 1, and you just have an x-axis reflection, we got decay. Okay, so graphically speaking, as we go to the left, we're either going up or down forever, because as we go to the right, we're leveling off at that asymptote. Now, notice how this limit, though, is specifically asking us about the left-hand side. So this is the one we got to be careful of, because it's either going to be positive infinity or negative infinity. Let's go ahead and think about what this graph might look like. Okay, so decay starts out high on the left, leveling out on the right. And if we flip it upside down, because of that x-axis reflection, it's now going to look like that. That's the only flip we do. Okay, so as we go forever to the left, it looks like this exponential function is going to go down forever. So the limit would be negative infinity. We doing okay so far? Okay, it's up to us to try to figure out what does the graph look like to help us with these limits. All right, let's try the next one. We have two negatives, one on the outside and one on the inside with the x. So both reflections. Our base value is between 0 and 1. So use your little shortcuts at the top. Growth or decay? Growth. Okay. So the further we go to the right, we're either going up or down, okay, away from that asymptote. Now in terms of the limit, we are specifically looking towards the right, so we need to determine what does this graph look like. Are we going up forever or down forever? So let's think about that asymptote. If this is originally a base between 0 and 1, okay, that's a decay graph. And if we have both reflections, okay, we have to flip it over the x and the y. We're going to get something like that. So it looks like as we go off towards the right, our graph goes down forever. Can we visualize both reflections, both flips? All right, let's try the next one. Both reflections, we have a negative on the outside and with the exponent in the power. This time our b value is 2, so that's bigger than 1. If we have both reflections with a base bigger than 1, we got decay. All right, so that means as we go towards the right, we are approaching the asymptote. And what's nice about this one is we are actually checking that right-hand side. Notice how we're going towards positive infinity. So in this case, the graph might not even be necessary because what's our asymptote? 2. Okay, so exponential decay, as you go towards the right, you approach the asymptote. The limit is specifically asking for the right, so we know the horizontal asymptote is 2. Okay, if this limit was towards negative infinity, we would have to try to sketch a graph to figure it out. But this one's a little nicer because we know it's going to approach the asymptote. All right, let's try the next one. We have a negative in the exponent. So that's a y-axis reflection. Our base is E, 2.718, so that's bigger than 1. Growth or decay? Yeah, decay. All right. So as we go towards the right, we should approach the asymptote, but the limit is asking us about the left. So that's either going to be a positive or negative infinity. Let's go ahead and try to figure out which one it is. So if the base is bigger than a 1, your graph is starting out as a growth. But if we were to reflect it across the y-axis, moving it left or right, it's now going to look like that. Your asymptote is located at 2. Okay, so based off of that rough sketch, as we go towards the left, our exponential function is going to approach positive infinity. You guys want to try number 6? See how you do? Any ideas? You got a 1/3 shot. Only one of 3 things is going to result here. What do you think, Joseph?
-4.
How'd you get that?
It's a flip of the x-axis.
Okay.
And since it's in between 0 and 1,
Yep.
it's a decay.
All right.
So, and if it's going to its right, it goes towards the horizontal axis.
There we go. Okay, so we know we have a decay graph, which means as we go to the right, we approach the asymptote, and this limit is specifically asking us about the right-hand side. So we must approach that -4 from the function. Did we catch that? Okay, let's check out the ones at the bottom. How are these limits a little different than the 6 we just did? Can you look at them?
They're not approaching infinity.
They're not approaching, right, that infinity, that left or right side. So how do we normally evaluate a limit? Good, Dan?
Substitution.
Substitution. All right, so you really only have to worry about decay, growth, reflections, all that stuff if you're approaching an infinity, all the way to the left or all the way to the right. If you're approaching a number, we're going to use the same techniques we talked about in the last few sections. Okay, always try direct substitution first. So if we were to plug in 3 in this case. Looks like we get e to the negative first plus 2. Now what I want to start to practice is simplifying or rewriting some of these things, because if this was a multiple choice question, for instance on the AP test, this might not look like one of the answers, like A, B, C, or D. They might rewrite it somehow. So we have to get used to rewriting things to make sure that our answer can match one of the possibilities. So maybe we can think about, is there some way we can rewrite e to the negative first? Do we know what a negative exponent does, or how we can turn a negative exponent positive? Yeah.
If you put 1 over e, because the negative does that.
Does that. Okay, so if you have a negative exponent, you can turn it into a fraction. Okay, you flip where that value is located. So instead of normally being in the numerator, we now move it to the denominator. Okay, so one possible way this might look like on a multiple choice is 1 over e plus 2. Okay, let's try a different way to rewrite it, just in case this is not one of the possibilities. How can we add fractions? Notice how we have a fraction plus 2. Yeah.
We put 2 as 2e over e.
Okay, let's multiply this 2 by an e up top and an e down below. That way we can get a common denominator. So now that the denominators are the same, we can have 1 plus 2e over e. All right, these 3 results all mean the same thing. Okay, any of those 3 could show up as a possible multiple choice answer. It's just that I don't know which one to show you guys or say is the final one, because I don't know which one might show up. So we have to start to learn how, even though we get the right solution and it doesn't show up on the possibilities, we have to rewrite it somehow to figure out which one it is. Okay, so we might, or we're going to have to start to get into that mindset of rewriting things if necessary. Let's go ahead and check out 8. Again, this is approaching a number, so we can try direct substitution. If we plug in negative 2, it's actually going to change positively because we have a negative in that exponent. Okay, so here's one possibility of how the solution might look on a multiple choice problem. Again, we have negative exponents, so maybe we can rewrite it. If we were to flip the location of the 1 over 2, it would now be 2 over 1, right, to the first. Or you can just write 2 there if you wanted to, plus 3. And notice how that's just simply 5. All right, so it might look like 1/2 to the negative first plus 3, but it also might look like 5. Notice how you might get confused, because if you just stopped here at the 1/2 to the negative first plus 3, and you didn't see anything like that, you might get a little frustrated, because you know you did it right. You just have to make it look like one of the possibilities. Is that okay? We're going to be doing that a lot this year too. All right, that's it for this section, real quick. Okay, exponential functions, only one of 3 things can happen if you go to the left or the right. Infinity, negative infinity, or asymptote. Okay, you have to think about what does the graph look like so that you can determine those limit results. There is a short homework assignment, guys. It's just 1 page, not even 1 page, the front of a page, page 41. Okay, so maybe you can try some of those tonight, and if you have any questions, you can bring them in tomorrow. All right, but these questions will not show up on your homework quiz tomorrow, just the other 2. We doing okay? All right.